Hey, welcome back to the channel. Let's continue our journey to BFS. Let's go ahead and read the question for surrounded regions. So given a 2D board containing X and O, and the letters O capture all the regions surrounded by X. A region is captured by flipping all the O into X and into surrounded region. So what does that mean? So let's go ahead and check one of the example right here. So we want to flip all the O's into X if the O is surrounded by X. So for example, this guy. So this small region of O are surrounded by X. So X is on top of this guy, on those guys, on the left of those guys, on the bottom of those guys, on the right hand side of those guys. So they're being surrounded by X. So we're gonna flip all the O's surrounded by X into X. And this guy, unfortunately, was not surrounded by X because it's in the boundary. In the bottom of this guy, we don't have X, and that's why this guy survived as O. So what we're doing is we're gonna convert all the O's surrounded by X into X, like a tongue twister. Okay. How do we do that? So of course we can do BFS or DFS. There are two ways to solve it. I know like Unifying probably can solve this as well. Since this week we're doing like BFS, let's go ahead and use the BFS mind to do that. So how should we approach this? And one of the observation we are seeing is that if the guy is on the boundary, this guy will not be surrounded, and that's the observation we are seeing. So as long as this guy is in the boundary, so we are not gonna see being covered. So can we do this? We start with all the boundaries. And then we check, hey, there's a guy in the boundary, and then we start exploring all the neighbors for this guy. And then so if there's another O is connecting with this guy, it will not be surrounded as well, because this guy, for example, this guy is O, and we're gonna have this guy is O, and this is O, and this is O, this is O, and this is O. All of them will not be surrounded because they are connected, and as long as this guy is survived, and the entire thing will survive. So now the solution is more obvious. We're gonna start with the boundary, and we're gonna start exploring from the boundary guy to all his neighbors and check if we have the brother, if we have the old brother, and we are exploring all the O's that connected with the boundary O. And for all of those O's, will survive. And for the rest, and then we can convert, for example, O into something else. So we can convert them into a hashtag or like other random parameter, random character. Once we convert that, and then we can loop through the entire thing, and whatever is not being covered, for example, we converted this guy, right, for this particular example. So this is the only guy will survive, so we convert this character into something else. And then later on, so for the rest of them, we're being surrounded by X, so we can convert O into X. So that's how we solve it. Okay, let's go ahead and write the code. I think the code is more like a self-explanatory. So for this problem, so let's go ahead and define the edge case. So the edge case is if the board is empty, right? So if you don't have the board, and we just return, so we don't have to return anything. And by the way, we're not returning anything. In this case, we are like modifying this board in place. Okay, so now we also need to define the boundaries. Is if the board is not empty, and we're going to define the row and the column. And once we have that, and we need to define the directions. And the reason I'm writing in this way as a static variable is because we need a recursive not recursive function, but a helper function. So I'm gonna use this in my helper function. And the reason I'm gonna use a helper function is because the BFS is very long, and I'm gonna call it multiple times. So it's better to abstract it. Okay, so we define all the 4 directions, and we can start writing the framework, like how we do that. So we are going to all the 4 boundaries. So all the way from boundary from here, and those boundaries. So we're gonna go over all the boundaries, and then so we're gonna check if the board. So I stands for the row, right? And our row is gonna be I, and we check the column. So we are moving row, and we checking the first column and the last column. So let's check the first column first. So if the first column is equal to 0, the O, and then we can start doing BFS. You know what? So let's abstract this first, BFS. So what's in the BFS though? The BFS will take in the board because we are modifying on top of the board, and we are given the directions, coordinates. So that's what we do, the coordinates. So we put in the board, and we put the coordinates, and I and 0. So that's the first column, and let's put the last column as well. So if the board I, and the last column is gonna be at -1 and equal to O, and we also do the self BFS. Okay, we put the board and I and -1. Oops, sorry. Okay. All right, so we are already tackled the first column and the last column, but now we're gonna tackle the first row and the last row. And the way we tackle the rows is by fixed column. So let's go ahead and fix the column. Okay, so if the board 0, the first row, and we move the column and equal to O, and then we do a BFS, and we put in the board, we do 0 and J is moving. Okay, and we do another one. If the board M-1, that's gonna be the last row, and we move the column. And if this is equal to the O, and then we also do a BFS. So we are gonna copy a BFS 4 times, and we're all gonna pass in the board. We pass in the corresponding coordinates, and that's how we do it. So for each point, so for each node on the boundary, we're gonna do a BFS, and we're gonna check, hey, if this guy's O, I'm gonna explore all the neighbors, all the connected O's, and I'm gonna see those guys. I'm gonna convert those O's into a hashtag or like other random characters. So that's what we're gonna do. So if we're gonna do that, and how do you actually do that? Since I wrote BFS, and I'm gonna just use BFS. And first of all, I need my boundaries, and I need a queue. That's the standard BFS. So collections.dequeue is a double-ended queue in Python, and I'm gonna put my initial position. So since we know the initial position is given, it's I and J is given in the input. So we start from that particular position, and then so like we mentioned, so since we are starting from the boundary and we want to convert this current spot into a random character, because on the boundary those will not be surrounded. If they're not being surrounded, I'll convert to something else called a hashtag. So let's do that. Let's make it equal to the hashtag. Okay, now we can start traversing, and we pop this out from the queue. And once we pop this out from the queue, and we can start exploring. In this case, we don't have the terminal position. Like when we write a BFS, we normally have some terminal condition, but now we don't. All we do is finding all the brothers and sisters that connected with my O. So I'm gonna explore all the 4 directions, so which we previously defined right here. And we're gonna calculate a new spot. So x will be equal to plus or equal to dx, and y will plus or equal to dy. Okay, and if x is less than 0, or x or y is less than 0, or x is greater or equal to m, or y is greater or equal to n, and then so we continue. We are over the boundary. We are reaching out of the boundary, so we're not gonna do anything about it. And if the board x and y will not equal to O, so okay, so we're not gonna do anything about it as well. I only want to find my brothers and sisters. If you're not in my family, so go screwed. And so now if we exclude all the conditions, so the thing left over is gonna be O. So if you are O, I'm gonna mark it as well as my brother. So, and then I'm gonna put you into my next operation. So I'm gonna start operating on top of that. So the queue will, this will be adding to the queue, and the while loop will have a next position, and then we start looping, and until like we find all the neighbors having O as my spot. Okay, so once we have that, so we're gonna mark all the O and the connected family into hashtag. So once we mark all of them, all the connected neighbors from the boundaries, and we already convert all of them to hashtag. And then one thing we can do is, and we're almost done. So we still have one step left to do. We're gonna loop through the entire board. We're gonna loop through the entire board, and we're gonna find out if the board is equal to the hashtag. Congratulations, we're gonna convert you back to the X. We're gonna convert you. Oh, I'm sorry. I convert you back to O actually, because that's where we're starting with. We are not converting O. Else if the board is equal to O, those O are never being converted to hashtag. That means they are being surrounded. They're being surrounded by X. So we're gonna convert those to X. Okay, I think we are done. Let's try this. 0J. Oh, this is supposed to be J. Did I have X and Y? Oh, oops, sorry. This is supposed to be, oh, I and J actually. You know what? So let's do this as I and J. And let's do this. Okay, that will be the new position. So let's try this. Okay. Wait, the board. And this is in line. Okay, perfect. So now we pass. Okay. Now we're done. I'll see you guys in the next video.